Let's take a closer look at the following simple experiment together. For this particular experiment, you'll need a power strip, nothing fancy or complicated, just a regular everyday plug that you might find in any home. And here, as you can see, we have a double outlet, which will be useful for our setup. The next item required for the experiment is this very short extension cord, which comes with a plug, a length of wire, and here is a socket at the end. And finally, the last essential element of the experiment will be a light bulb, which will help us observe the results of our setup. This is a compact fluorescent lamp, which is a type of energy-saving light bulb. So let's go ahead and see the experiment in action. The experiment proceeds as follows. We take this power strip, which is a device that allows multiple electrical devices to be powered from a single socket, and I plug the power strip in here like this, making sure it is securely connected. Then I put the plug here, and now we've created a little loop. Oops, let me plug it in properly to ensure a good connection. Normally, under these circumstances, this setup doesn't do anything, right? In reality, it doesn't do much either. But according to some reports, this is supposed to be able to generate energy. I'll put it down here at the end of the table. And this energy generation supposedly happens like this. I take a compact fluorescent lamp, here it is, I put it here, and the compact fluorescent lamp generates so much energy that it lights up. In fact, what happens if we take another compact fluorescent lamp? There's nothing special about this, it's just a concept. I put it down, and it's so energetic that now this one lights up too. And of course, I could keep going. If I take yet another compact fluorescent lamp, I put this one here with the others, and it lights up as well. And I could keep going with the next one, and the next one, and the next one, and they all work. Now, I'll take away this compact fluorescent lamp, and this other one, and this last one too. And now I'll show you the essence of the whole thing. This thing here, this is nonsense. It didn't actually do anything. It was just a trick. Because if I put the compact fluorescent lamp on the table, it lights up anyway. And if I take another compact fluorescent lamp, it starts to light up too. So both of them are lit. Or if I take a different kind of compact fluorescent lamp and put it here, it lights up nicely as well. So what's the trick? The trick is down here, under the table. Let me show you exactly. The main point is there's a Tesla coil located under the table. It's approximately a 30 centimeter tall coil, which is quite compact. At the end of the coil, there's a ball made of aluminum foil. Here is a secondary coil, a lithium-ion cell, a switch, and a circuit. So let's see exactly what this does. It's important that there's a power source. These compact fluorescent lamps, for example, this one didn't light up because of that. It wasn't because it was in a good mood or because it could somehow magically extract energy from the air itself. It lit up because these lithium-ion cells were actually part of the setup, and they're already charged, so the energy source was definitely, without a doubt, these cells. There's also a switch here. This is the switch. And here's the transistor. Let me show you the transistor. It's mounted on a heatsink for cooling. And there's also a resistor. That's the resistor here. Actually, two 100 nanofarad capacitors connected in parallel. And here is a coil, this pink wire, which is wound 3 times around. So the way it works is, I turn on the switch, and if I take a compact fluorescent lamp in my hand and start bringing it closer, when it gets close enough to the coil, from that point on, this fluorescent lamp, and it will light up. If I take another one, obviously that one will start to light up too, just as expected. And let's keep going. If I take yet another one, it will also start to light up, just like the previous ones did. Unfortunately, I can't fit more than 4 at the moment, but as you can see, these compact fluorescent lamps are working properly and functioning as intended. There were 300 turns wound here in total. Here, well, it was wound up like this, in this particular manner, as you can see. At the very end of the wire, a standard golf ball was carefully attached right here, and this particular golf ball was thoroughly coated with a layer of aluminum foil. 3 complete turns were meticulously wound onto this coil. This was the pink wire that I previously showed you in the earlier demonstration. So, to be clear, there are 3 turns in total. And in total, there are also 3 more outputs located right here. Now, what exactly is needed for this entire setup to work properly? This is in fact nothing other than a transformer. More specifically, it is a resonant transformer. With resonance, you need inductance. So this will be the inductance. And what the ball provides is capacitance. So that will be the capacitance. So the capacitance added by the ball and the inductance in this coil, you can calculate the resonant frequency using the following formula: 1 over 2 pi times the square root of LC. This coil resonates at that frequency, which in my case is about 45 megahertz. What happens when I turn on the switch? Then the 12 volts appears at this point in the circuit, and this transistor opens up because of the base current that is now flowing into it. So as a result, current starts to flow in this direction. It flows smoothly and nicely through the coil, continues onward toward the transistor, passes through the transistor itself, and then flows down into the ground, back to the ground connection. In this way, the circuit is basically closed and completed. That's how the current flows through the entire circuit. If this coil, that big coil right here, wasn't present in a circuit, then this transistor would burn out in an instant, almost immediately, because a large current would constantly flow through it. There would be a significant voltage drop across it. The power dissipation would be very high, and it would fail quickly. But the trick is that I connected this point, which is one end of this 300-turn coil, right here to the base of the transistor. When the current appeared here, then in the coil here, some flux. The flux induced a voltage in this 300-turn coil, and as a result, the base of the transistor switched off for a moment. So the story goes like this. The transistor turns on, then turns off, then turns on again, and then turns off again. And this cycle repeats. It does this periodically, over and over, because as soon as the flux here disappears, meaning the magnetic field collapses at that very moment, the resistor opens this transistor again, and an oscillation occurs. This is the 45 megahertz I described earlier. So the whole thing oscillates at 45 megahertz. If I accidentally touch this little sphere, I just feel a slight unpleasant tingling sensation, and the current flows on the surface of my skin. And at this point, it seems like nothing is really happening, but as soon as I bring a compact fluorescent lamp close to this coil, the lamp immediately lights up as a result. If I bring another fluorescent tube close, it also starts to light up, and I could keep going like this. If I place my fluorescent tube lower here, less and less energy is channeled out. Obviously, the most energy is channeled out here. You can also see it by the brightness of the compact fluorescent tube. That's how it works. What's really good about it is that this way you can transmit energy through the air. Of course, the efficiency is very, very low. The circuit is very simple. The electronic devices. It interferes with them extremely, causing significant disruption. That's the whole circuit, built together from the air like this, assembled carefully. There's the transistor, which is a crucial component. By the way, there's also a transistor that I didn't solder in, which you can see here. You can see its type as well, clearly labeled. This is a very well-proven and reliable type. Some people go overboard and use not 3 turns, but 4 or even 5 turns of wire. The more turns I use, the worse this thing will work, reducing its efficiency. The fewer turns I use, but if I use too few turns in the coil, then this transistor will get really, really hot, which is definitely something we want to avoid. The coil shouldn't start from here, but instead it should begin a little higher up, about a centimeter higher than this point. That's all there is to it. So that's exactly what I wanted to show you today. And now I'll say goodbye. See you next time.